Hello everyone, welcome to today's lecture. So yesterday we studied about the two different types of acids and two different types of bases, that is strong acids, strong bases, weak acids, weak bases. And what do you mean by an alkali? What is an alkali? An alkali is a substance. An alkali is a base which is soluble in water. You had studied the examples also. Then you studied about the pH. The pH ranges from 0 to 14. 7 is taken as neutral. Below 7 is taken as acidic. Above 7 is taken as basic. Okay. Now today we are going to start with the study of reactions. Okay. The reaction of acids and bases. The different reactions which acids and bases undergo. Okay. Now the first one is called as neutralization. It is a process called as neutralization. Now what do you mean by neutralization? Neutralization reaction. It is a type of reaction in which an acid reacts with a base to form salt and water. I repeat, neutralization is a type of reaction in which an acid reacts with a base to form salt and water. Okay, so we may see, take page number 65. The first one is neutralization. There is an activity given there. What you have to do, you have to take 10 ml dilute HCl in a beaker, and with the help of a glass rod you have to check the pH of the solution. What will be the pH of the solution? It will be acidic. Now what you have to do, you have to add NaOH into it. Okay, drop by drop. Whenever you are adding NaOH, you have to check the pH. You may see that it moved towards neutral. Okay, it moved towards neutral. That means it moves from 0 to 7. Okay, till 7. It will come at 7 and it will go above 7 also if you continue adding NaOH at times. Okay, but if the amount of dilute HCl in the solution is finished, the neutralization is finished, then the pH does not change. Now there are some questions given. What do you find? Stop adding NaOH when a green color appears on the pH paper. That is when the pH of the solution becomes 7. Now what is happening? Now when you are adding NaOH to HCl solution, you know HCl is an ionic compound. NaOH is also an ionic compound. HCl is made up of HCl is made up of H plus and Cl minus ions, and NaOH is made up of Na plus and OH minus ions. HCl is an acid and NaOH is a base. So when you are adding, they dissociates. The dissociates means separates. That means H plus and Cl minus get separated and Na plus and OH minus get separated. This is the complete reaction which is taking place. What is the reaction? Acid, okay, that is HCl. It reacts with NaOH to form NaCl and H2O. So an acid reacts with a base to form salt and water. This is basically what is neutralization. Now what is happening? The HCl gets dissociated into H plus ions and Cl minus ions, and NaOH gets dissociated into Na plus and OH minus ions. Okay, now this H plus and OH minus will combine together to form H2O, and Na plus and Cl minus will combine together to form NaCl. This is the reaction what is taking place, which has been given in the second paragraph. Okay, so what is the basic reaction? H plus ions combines with OH minus ions to form H2O. So an acid will react with a base to form salt and water. Okay, now you may see on page number 65, second paragraph, both HCl and NaOH dissociate in their aqueous solutions. Addition of NaOH solution to HCl solution is like adding larger concentration of OH minus ions into large concentration of H plus ions. The excess OH minus ions combine with excess H plus ions to form H2O molecules which mix with the solvent water, and they have given the net reaction which is taking place. This is the net reaction which is taking place. So if you are having a question on explain neutralization, okay, you may write the definition of neutralization. What is neutralization? A neutralization is a type of reaction where an acid react with a base to form salt and water, and you have to explain with the help of HCl and NaOH, and you have to write all these three equations. Now there is a box on page number 65 given below. Okay, the acid and base will combine together to form salt and water. Okay, they will combine together to form salt and water. Now I'll tell you the acid. The first one is nitric acid, that is HNO3, reacting with potassium hydroxide KOH to form KNO3, that is potassium nitrate plus water. Here potassium nitrate is a salt. Now salt is a general term which is given to compounds which do not have H positive or OH minus ions. You may remember this. If a compound is having H plus ions, it is an acid. If it is able to form OH minus ions, then it is a base. If it is not able to form neither H positive nor OH minus, then it is a salt. Here you may see there is no H, there is no OH. It cannot form H, it cannot form OH. So it is a salt. That way you may remember. Okay. So the next one is sulfuric acid, that is H2SO4 plus NH4OH, that is ammonium hydroxide, to form ammonium sulfate plus H2O. Okay, the third one is bromic acid, HBr plus potassium hydroxide, that is KOH, giving potassium bromide plus H2O. Okay, now in all these reactions there is an acid, there is a base, combining together to form salt and water. They will give you the way it has been given in the textbook, the complete table they could give, or they could give either one or two as a question, but it will be a fill in the blank question. Okay, now we may move on to page number 66. Always remember, you may mark that in the neutralization reaction, an acid reacts with a base to form salt and water. That sentence you can write as the definition of neutralization reaction. Towards the right, use your brain power question. What would be the definition of an acid and a base with reference to the neutralization reaction? Now what could be the definition of an acid? You may write, an acid is a substance that reacts with a base to form corresponding salt and water. I repeat, an acid is a substance that react with a base to form corresponding salt and water. Okay, now what will be a base then? Similarly, a base is a substance that reacts with an acid to form corresponding salt and water. I repeat, a base is a substance that reacts with an acid to form corresponding salt and water. Okay, so that is about the reaction between acids and bases. Now the next property is reaction of acid with metals. Metals generally react with dilute acids to form that particular salt and hydrogen gas. So you could get an objective question, dash gas is liberated during when a metal react with an acid. Which gas is liberated? It is hydrogen gas. They have given an activity there. You have to take a test tube. In the test tube you have to take magnesium ribbon, and into that you have to add dilute HCl. Okay, now what will happen? Magnesium, here I have written the reaction, it is there in the textbook also. Magnesium will react with HCl to form magnesium chloride and hydrogen gas. S means solid. Magnesium, which is a solid, it will react with aqueous, that is it is in the form along with water, Okay, in the liquid form HCl, it is dilute to form MgCl2, which is aqueous, that is inside that solvent itself, and H2, which is in the form of a gas. Now that H2 will come up in the form of bubbles. They have shown bubbles. The H2 will come outside. If you show a candle at the mouth of the test tube, it will burn, it will explode. It will burn with an explosion because hydrogen gas is inflammable. Okay, so that is a reaction. The first reaction for metals react with dilute acid to form salt and hydrogen. Now the next is zinc react with sulfuric acid to form zinc sulfate and hydrogen. Copper reacts with nitric acid to form copper nitrate and hydrogen. Actually, generally copper does not react with HNO3. It is a weak acid. Okay, it generally does not react but cannot say. In this reaction, they have given it as a fill in the blank, so I have filled it up accordingly. Okay, now actually it is a different type of reaction which you are having in your 10th standard. So these are the reactions when a metal react with an acid to form salt and hydrogen. You may fill this in your textbook itself. Now the next is reaction of acids with oxides of metals. Okay, so this is a topic where reaction of acids, we are studying about the reaction of acids with some other compounds and reaction of bases with some other compounds and the reaction between acid and base. So we have studied about acid and base. Acid and base will react together to form salt and water. The next we studied was about metals with dilute acid. Okay, metals with dilute acid will give salt and hydrogen. Now the next is reaction of acids with oxides of metals. There is an activity given on page number 66 towards the end. You may see you have to take some water in a test tube and add a little red oxide, that is ferric oxide, to it. Now add a small quantity of dilute HCl to it. Shake the test tube and observe. Does the red oxide dissolve in water? No, it does not dissolve. It is insoluble in water. What change takes place in the particles of red oxide on adding dilute HCl? Okay, now what happens when you are adding HCl to it instead of water? So when you are adding HCl, this reaction take place. Fe2O3, that is red oxide. This also could be an objective type question. What is red oxide? The chemical formula, the molecular formula of red oxide is Fe2O3. What is the chemical name? It is ferric oxide or iron oxide. Okay, so this Fe2O3, it will react with HCl, that is acid, to form FeCl3. Okay, here I have written it will be FeCl3. Okay, FeCl3 plus H2O. Okay, FeCl3 plus H2O. This is ferric chloride, which is soluble. So it will become soluble and it will give a yellow color. Which color? That is also important. It is yellow in color. The explanation have been given on page number 67. The answer for both the questions are also there on page number 67, first paragraph. Okay. Now the next is metal oxide. So this is a metal oxide which is going to react with an acid. Okay, so metal oxide when react with acid to form salt and water. Again I repeat, metal oxide react with acid to form salt and water. So when a salt and water is formed, salt and water is formed when acid and base react. So if this is an acid, this should be acting as a base. It should be basic in nature. Okay, that means the metal oxides react with acids to form salt and water, hence they are basic in nature. So you should be remembering this sentence, metal oxides are basic in nature. Okay, now the reactions given in the textbook, the fill in the blanks part. Calcium oxide, which is a solid, it is a metal oxide, reacts with HCl to form calcium chloride and water. Okay, magnesium oxide, which is a solid, it will react with HCl, that is AQ stands for aqueous. Aqueous means in water. Okay, MgCl2, which is in solvent form, solution form, and H2O, that is water. Zinc oxide will react with hydrochloric acid to form zinc chloride and water. Aluminium oxide will react with fluoric acid to form aluminium fluoride plus water. Okay, so metal oxide react with dilute acid to form salt and water. These reactions you have to learn. Now there are two questions given in the second paragraph. What type of compound is a metal oxide with reference to neutralization reaction? It is a basic compound. It is a base. Explain the statement metal oxides are basic in nature. Why metal oxides are basic in nature? Because I have written the statement here. Metal oxides react with acids to form salt and water. Hence, they are said to be basic in nature. Okay. Now the next is reactions of bases with oxides of nonmetals. This is reaction of acids with oxides of metals, and this is reaction of bases with oxides of nonmetals. This is the exactly opposite reaction. Now a non-metal oxide react with a base to form salt and water. I repeat, non-metal oxide react with a base to form salt and water. So CO2, this is a non-metal oxide. C stands for carbon. It is a non-metal. The oxide of carbon is carbon dioxide. Carbon dioxide react with sodium hydroxide, which is a base, to form sodium carbonate plus water. Carbon dioxide reacts with potassium hydroxide, which is a base, to form potassium carbonate plus water. Sulfur trioxide, which is a non-metallic oxide, react with sodium hydroxide to form sodium sulfate and water. So non-metallic oxides react with base to form salt and water. So non-metal oxides are acidic in nature. As these are acidic in nature, they do not react with acids, and as these are basic in nature, they do not react with bases. So metal oxides react with acids and non-metal oxides react with bases to form salt and water. This much you have to remember. Now there are some compounds which can react with both acids and bases. Some oxides, okay, some oxides can react with both acids and bases. Such oxides are called as amphoteric oxides. I have written the definition. Amphoteric oxide, an oxide that react with both acid as well as bases. They are called as amphoteric oxides. In our textbook, they have given an example, zinc oxide. Okay, actually zinc oxide and aluminium oxide are examples of amphoteric oxides. What are amphoteric oxides? Amphoteric oxides are those oxides which can react with both acid and base to form salt and water. Okay, now in our textbook, page number 67, use your brain power question. Write down the chemical equations for both these reactions. That means of zinc oxide and aluminium oxide. So zinc oxide will react with sodium hydroxide to form sodium zincate plus water. You may copy these equations in your textbook itself. You may write this on the next day in your notebook or the same day itself. Aluminium oxide plus sodium hydroxide gives you sodium aluminate plus water. These two reactions you have to learn. They haven't asked the equation of these oxides with acids. Here they have shown the reaction of these oxides with acids. They haven't asked about bases. So you don't worry. Sorry, they have asked with bases. They haven't asked about acids. So you don't worry, you have to learn these two equations only. Okay. Next question. Can we call Al2O3 and ZNO? The Al2O3 is aluminium oxide and ZNO is zinc oxide. On the basis of these reactions, yes, we can call them as basic because it will react with acid. Can we call them as acidic? Yes. Why? Because it reacts with bases to form salt and water. Define amphoteric oxides and give two examples. What are amphoteric oxides? I have written it here. You may copy it in your textbook. An oxide that reacts with both acid as well as bases. Example, ZNO, that is zinc oxide, and Al2O3, that is aluminium oxide. Okay, now you may write these answers in your textbook. Now the next is reaction of acids with carbonates and bicarbonates of metals. So the carbonate salt of a metal, it will react with dilute acid, which will give you another salt of the metal plus carbon dioxide plus water. On page number 67, they have given an activity. You have to take two test tubes. You may see here there are two test tubes. In one test tube, consider in this black one, okay, you are taking the carbonate salt of the metal and the acid. Okay, you are taking the reactants in this, and this is another test tube which contain lime water. Now there is a bent tube which is connecting this. Okay, there is a bent tube which is connecting this like this. Okay, now what will happen? The reaction will take place in this test tube. What is the reaction? The carbonate will react with the acid to form salt plus carbon dioxide gas plus water. Okay, now what happens to carbon dioxide? It will come up, it will pass through the bent tube and enter into the test tube which is containing lime water. The test tube which is having lime water, it will turn milky. Okay, it will turn milky. Now this is a confirmatory test to show that the gas which is produced during the reaction is carbon dioxide. Okay, you may remember this as long as you do chemistry. Okay, the confirmatory test for carbon dioxide gas, that means you are doing any type of reaction, and if you want to check what type of gas is produced, you may pass the gas through lime water. If the lime water turns milky, then the gas which is produced is carbon dioxide gas. So we'll come to the reactions in the textbook. The carbonates react with dilute acid to form another salt of the metal plus carbon dioxide gas plus water. So here sodium carbonate react with hydrochloric acid to form sodium chloride plus carbon dioxide gas plus water. Sodium carbonate react with sulfuric acid to form sodium sulfate, which is a salt, plus carbon dioxide plus water. Calcium carbonate plus nitric acid gives calcium nitrate plus carbon dioxide plus water. Potassium carbonate plus sulfuric acid gives potassium sulfate plus carbon dioxide plus water. You may fill in the boxes, okay, fill in the blanks. Next is bicarbonate plus acid. Now bicarbonate salt of the metal plus dilute acid will give you another salt of the metal plus carbon dioxide plus water. In both the cases you may see the products are the same. Okay, the products are similar. Another salt of the metal plus carbon dioxide plus water. In your textbook they haven't written this water, I think you may write it. Now sodium bicarbonate, it will react with hydrochloric acid to form sodium chloride plus carbon dioxide plus water. Potassium bicarbonate plus nitric acid will give potassium nitrate plus carbon dioxide plus water. Sodium bicarbonate plus acetic acid, that is CH3COOH. I have written the name here. You may write in your textbook. Sodium acetate, it will give you sodium acetate plus carbon dioxide plus water. So whether it is a carbonate or a bicarbonate, what are the products formed? It is another salt of the metal plus carbon dioxide plus water. Okay. Now the next topic is salts. There are basically three different types of salts: acidic, basic and neutral. There are three types of salts. What are they? Acidic, basic and neutral salts. Okay, now salt means it is not always neutral. Neutral means it gives the pH 7. Acidic means it shows a pH less than 7, and basic means it shows a pH greater than 7. Okay, so there are three types of salts: neutral, acidic and basic. Now on page number 68 there is a try this question below the heading salts. Prepare 10 ml aqueous solutions from 1 gram each of sodium chloride, ammonium chloride and sodium bicarbonate. You have to measure the pH of the solution and you have to classify them. Okay, so I have written the answer here. Ammonium chloride shows ammonium chloride shows a pH which is less than 7. That means it is an acidic salt. Sodium bicarbonate, it gives a pH greater than 7. That means it is a basic salt. Okay. Sodium chloride shows a pH equal to 7. That is a neutral salt. Now how can you prepare a neutral salt, an acidic salt, or a basic salt? Strong acid plus strong base will give you a neutral salt, and weak acid plus weak base will give you a neutral salt plus water. I haven't written plus water here. Strong acid plus weak base will give you acidic salt because it is strong acid and weak base. Similarly, weak acid and strong base will give you a basic salt. Okay, this you may write in your textbook. It has not been given directly. Okay, you may write it there so that it will be easy for you to understand. Okay, now there is a question again towards the end of page number 68. Classify the following salts into acidic, basic and neutral. Now how you could classify into acidic, basic and neutral? Basically you should be knowing the names of strong acids, weak acids, strong bases, weak bases. Okay, this you should be able to understand first. Okay, if you are not able to understand, you may just learn it. There are two questions in your chapters. First is this and one is there in the exercise. So the acidic salt is ammonium nitrate, basic salt is sodium carbonate and sodium acetate from those which have been given to you. Okay, neutral salt is sodium sulfate, potassium chloride and sodium chloride. Now here you may see sodium sulfate could be formed by the reaction of sodium hydroxide and sulfuric acid and sodium hydroxide. Okay, both are strong acids, both are strong. Sulfuric acid is a strong acid and sodium hydroxide is a strong base. So strong acid plus strong base will give you a neutral salt. Okay, so these are neutral salts, these are basic salts, these are acidic salts. This you may write on that page itself. You may learn this today itself. So today we learnt about the reactions of acids and bases. First is neutralization, second is the reaction of metals with acids. Then we studied about metal oxides plus acids, non-metal oxides plus bases, and the reactions of carbonates and bicarbonates, and the last topic, salts. If you are having any doubt, you may ask. Go through the textbook very thoroughly. Okay, thank you.